Hi everyone. So today we are going to discuss this example of sequence of function. See what is defined here. Fn is equal to, so its definition is 0 for x is equal to 0 and n e raised to minus nx for x lies in that interval. What we have to prove? We have to prove that this convergence is not uniform convergence. So first of all we will try to find its pointwise limit and then we will discuss for a uniform convergence. So obviously I will discuss here two cases. First, for x is equal to 0, so x is equal to 0, fn of 0. So for x is equal to 0, it's 0. I will take limit of both sides. 0 is constant, so if you apply limit it will be 0. Let us go for the second case. For x is not equal to 0, so in this case fn of x is n e raised to minus nx. You know that when we have a negative power we write in denominator, so n upon e raised to nx. Do you know the expansion of e raised to x? Expansion of e raised to x is 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on. So this expansion I am going to use here, and 1 plus nx plus n square x square by 2 factorial plus and so on. So if you reduce the denominator, value will get increased, so that's why this is greater, this is less than or equal to. I'm removing all the terms, just simply I will write n square x square by 2 factorial. So this 2 factorial is in denominator of denominator, it will shift to the numerator, so 2n upon n square x square. N will get cancelled, so this is 2 upon nx square. Basically fn is exponential function, so it cannot be negative, so therefore we get 0 less than or equal to fn of x, which is less than or equal to 2 upon nx square, which tends to 0 as n tends to infinity. That means right hand side tends to 0 as n tends to infinity. Getting? So see, left hand side we have 0, right hand side also moving towards 0. So by sandwich theorem, can you guess? By sandwich theorem what can I write? Yes, by sandwich theorem, limit n tends to infinity, fn of x is equal to 0. Getting? In first case we have got 0 and in second case also we are getting 0. So therefore we define a pointwise limit f from 0 1 to r as f of x is equal to 0. So therefore we can say, therefore our fn converges to f pointwise, pointwise on closed interval 0 1. So now we have to prove that it is not uniformly convergence. So actually there is one result, there is one method, so using that you can prove it is not uniformly convergent. What is that result? So if fn converges to f, okay, pointwise, fn and f are integrable. Getting? R integrable means Riemann integrable, and limit integration fn is not equal to integration f, then that convergence is not uniform convergence. Okay, so this is one method. So out of that, only first thing we have done, fn converges to f pointwise. Now we will prove that fn and f are Riemann integrable. See, exponential function is there, so that's why it is clearly continuous. Fn is continuous and every continuous function is Riemann integrable. Okay, so see, we are doubtful about at 0, so maybe at 0, so it is not continuous, so no problem. It has, if it has finite discontinuities, then also it is Riemann integrable. If you talk about f, it's a constant function and every constant function is Riemann integrable. So that's why the second thing is also so much obvious, that fn and f are integrable. So just these two things I will mention here. Every function having finite discontinuities is R integrable. So therefore we can say, implies fn is R integrable. Okay, and this is true for all n. here f is constant implies, since every constant function is R integrable. Okay, so now we have to simply complete two things, that sorry, one thing only, that limit of integration is not equal to integration of f. First two things already we have done. Let us go for the last one. So consider integration 0 to 1 fn of x. What is definition of fn? You remember? 0 to 1. Yeah, what is fn? Fn is, yeah, it is only for 0, huh? We have to consider this one, n e raised to minus nx. N is constant, will come outside. E raised to minus nx. What is the integration of e raised to minus nx? Yes, e raised to minus nx upon minus n. The constant always write in denominator, 0 to 1. N will get cancelled. Minus will come outside. Let us put 1 first. Let us put 1. So e raised to minus x. If you put 0, e raised to 0, 1. So this is 1 minus e raised to, sorry, here n I need to write, n e raised to minus n, which is equal to 1 minus, which is equal to 1 upon e raised to n. So if you apply the limit, if you apply limit on both sides, okay, so 1 is constant, it will be same, and here if you put to infinity, e raised to infinity is infinity, and 1 upon infinity is 0. So that's why if you put infinity, e raised to infinity, infinity, 1 upon infinity, 0, 0. So it's 1. So let us go for the second side. See, this side we have done. So let us go for integration f. What is our f? F is 0. Integration of 0 is 0. So therefore what can we conclude? Here we have got 1. Left hand side is 1 and right hand side is 0. So that's why both of them are unequal, right? So that means all three conditions are satisfied. So therefore we can say it is not uniform convergence. This Fn is not uniformly converge to F on closed interval 0, 1. Thank you.